I'm now going to do chapter 2, number 27. Number 27 says here that there's a car traveling at 30 meters per second, runs out of gas while traveling up a 10-degree slope. Alright, so we have a car. This is a 10-degree slope. Physics, we call them inclined planes. Car runs out of gas, and it's going at a speed of 30 meters per second. So the initial velocity is 30 meters per second. All right, one thing I didn't tell you, but is in the chapter, is that if you were on a slope, gravity, or the acceleration, is going to be g times the sine of the angle, or this is the bank angle. In chapter 5, we'll figure out where this comes from. But for chapter 2, 3, and 4, if you ever give you one on an inclined plane or a slope like this, just say that the acceleration is g times the sine of the angle of the slope. And they want to know how far up the hill. So we want to know the distance it goes before it stops. And I'm going to add to this, so we want to know the distance it goes. I also want to know the time it takes. And to do this, we're going to use one of our constant acceleration equations. And the easiest one here is the first part, to find out the distance. We don't have time. So if we don't have time, usually the best one to use is this one. Where x is the distance, the initial position is going to be 0. So this is going to be 0 here. And we want to solve it for x. So I'm going to rearrange this. I'm going to subtract the v0 squared. And I'm solving for x, so I'm going to divide both sides by t. I'm going to get x is equal to v squared minus v0 squared over 2a. But remember, a is g sine theta. But I got to be careful. If I'm making this positive, meaning it has a positive initial velocity, then acceleration is in the negative direction. So this is going to be x is going to be equal to v squared, but that's 0 squared, minus 30 squared, over negative 2 times 9.8, which is g, times the sine of the angle, which is 10 degrees. Remember, I substituted in a is equal to g sine theta right here. If you didn't put the negative in here, then you would end up with a negative distance, which doesn't make any sense. So make sure you're careful about your signs. When you put all that in, you get the distance that the car travels is 264 meters. And you have 3 sig figs because it's actually 30.0 meters per second. Now let's do the time. The easiest one for the time is to do this one and solve that for time. You could do the other one since we know the distance now, but this one's the easiest. So I'm just going to solve this for t. So I'm going to move the v0 over here, so I get v minus v0 is equal to at, or t is equal to v minus v0 over a. Or in this case, t is equal to, the final velocity is 0 minus 30 over negative 9.8 sine of 10 degrees. Remember, the acceleration is negative. When you do that, you get the time it takes is equal to 17.6 seconds. And that's how you do chapter 2, number 27.